Good morning, my name is Avinash and my matrix number is 56952. Today I'm going to present lab 3 on how this ladder diagram operates. This diagram represents an automatic tank system which consists of two materials, which would be material A and B. This diagram consists of three level sensor for the detection of both the materials and the entry level. It also consists of heaters and temperature sensors. The tank operates in a way where when both materials are accumulated in the tank, the agitator motor will run until a predefined temperature is reached. First, let's look at the first network. When the push start button is pressed, there are current flow. You can refer the blue line for the current flow. That indicates the current. Since I pressed the push up button, there is a control. If I left the booster, the system is still going on. This is because there is the function of the left is to continue the operation even the push start button is released. So in order to stop the current flow at the first coil, what we need to do is press the push stop button after we press the push stop button. Okay, the current will be blocked. After we press it, the current will be blocked. Okay, alright, this is the second network. The coil on the first server act as an input for the second network. The output of the second network is the inlet valve 1, as you can see. So it is the output for the second error. So the output waveform will be turned on when empty level switch on the tank is turned on, and the inlet work will be turned off. Okay, after the level of material, you can see a sensor is detected. So if the empty level switch is turned on, there is current, there is the, as you can see, there is the current, the system will be going on. If we turn off the empty level switch, the system is going on, because as you can see, it is less well. So that's why. This is because in order to stop the inlet valve F1, the only thing is the level of material. Okay, when the sensor detects the material, automatically the inlet valve will be turned off, as you can see. Okay, next on we are moving to the third network. Okay, actually the third network is actually the same as the second network. Okay, the cycle on the coil act as an input for the third network. Okay, and the output of the third network, as you can see, is the inlet valve 2. Okay, in order for you to operate the inlet valve 2, okay, you can see the level of the material A sensor should be on. Okay, so in order to stop the inlet valve 2, the level of material B should be turned on. Okay, so as you can see, since the level of material A is turned on, okay, there is the current flow, which I stated, the blue color line, still going on. Okay, so the inlet valve 1 is valve 2, which is operating. Okay, if the level of material B reaches the sensor for the level of material B. Okay, sorry, as you can see, the level of material B, when it runs, you can see the current flow will be blocked. Okay, and the inlet valve 2, you can see it will be stopped. There's no more current running there. The level of material A sensor is turned on, or it turned on. It is never turned on the current flow. Okay, because as you can see, even though it's still going on, why it's going on is because it is latched. Okay, in order for it, we need to stop the material inlet valve. Okay, as you can see, there's inlet valve 2, right? You have to stop it, because that's why the sensor detects the liquid of the material B. Okay, so if the sensor is detected by the material B, the current flow automatically will be stopped. Okay, as you can see in the video above, it will automatically stop. Okay, and now we are moving on to the fourth network. Okay, the fourth network of the ladder diagram. Okay, however, if you see in the fourth network, unlike the other two networks, there are two outputs, okay, which is as stated, which is the heater and the agitator motor. Okay, so can you if you can see the previous networks, the cycle on actors are input for the network. So there is a n which is which there is an n which is the level of material B in short, while this network is to operate the heater and the agitator motor. That's the main function of the fourth ladder diagram. Okay, in order for it to operate, both the outputs must be detected by the sensor and the level of material B. Okay, in order to stop the operation of the heater and agitator motor, the temperature sensor should be on as per the process of the system. Okay, when this happen, the tank, as you can see, the tank will be heated until it reaches a predefined temperature. Okay, as you can see, there is a current flow since the level of material B is turned off, but there is no current flow if we turn on the material B. Okay, to be in exact, when you turn on the material B, there is a current flow and the heater in the exact motor is turned on. So in order to stop the overall process for the network, what we need to do is we turn off the temperature sensor. So this means that if the tank reaches its predefined temperature and the process of the heater and agitator motor is, you can see that that's when it will reach. So that's for 4. Now we are moving on to the fifth ladder diagram. Okay, the fifth ladder diagram. Okay, fifth, as you can see in the previous networks, the cycle act as a input, and there is a pressure sensor outlet valve, empty level switch, and outlet valve as a output. The process of this network is actually to control the output